In this college algebra video, we will be discussing the basics of functions and their graphs. Please press pause and read through our objectives for this lesson. All right, first let's start talking about, we have to be able to define a function. Before we can do that, we have to be able to define a relation. A relation is just any set of ordered pairs, and it can be represented as ordered pairs. It could be represented in a diagram. There's lots of different ways they can represent it, but you're going to have components from the first part of the ordered pair, so the first coordinate, and that's called the domain of the relation, and the second set of numbers is called the range. And again, this could be done graphically or with an ordered pair. All right, so let's just jump right to an example. All right, find the domain and range of each. Okay, so let's start with our domain. Okay, the domain is going to be the x values of each of these ordered pairs. Notice none of them repeat, so when we write out the domain, we just write each number in order from smallest to largest. Do not write any repeating values. You only have to write them once. Same thing for the range. Notice each of the values is unique, and so I'm just going to go from smallest to largest. Those little squirrely brackets, again, they just mean that's my set. So my domain is this set of numbers, my range is this set of numbers. All right, so that is just a relation. Really straightforward, nothing crazy. Okay, a function, however, has a special relationship. It is a relation, but it has a special relationship such that each element in the domain corresponds to exactly one element in the range. What that means is you cannot have any repeating domain values. If you have a repeating domain value, then you have that same domain value going to two separate elements in the range, and you cannot have that. So make sure that you make a note. We're looking for those repeating domain values. So here, determine whether relation is a function. Okay, so let's look at, again, domain values. That's all we need to look at. 1, 3, 6, and 8. Nothing is repeating, so that is a function. Now, if one of those repeated, then it would not be a function. All right, functions written as equations are very simple. That just means you can solve the equation for y. And you will have a unique output on the other side. So you definitely do not want to see any pluses or minuses, like if you're doing square roots or anything like that. That would set you off that it is not a function. But you want to be able to just solve for y. All right, so determine whether this defines y as a function of x. So here's our y. Let's get it by itself. So I'm just going to subtract the x squared from both sides. And then to get the y completely by itself, I have to take the square root of both sides. And remember, when you take the square root, you have to have that plus or minus. So there is the equation. You get y equals, notice it's got the plus or minus though. And because of this plus or minus, that's going to tell us that it is not a function. Okay, because we're going to get a positive value and a negative value for every x we put in. All right, if you do have a function, you get special notation. Instead of writing y, so instead of writing the y, you're going to write f of x or f at x, depending on which textbook you use. So it just means that it tells you right away. If you see that, you know it's a function. You don't even have to think about it. So we know right away anything that's written in that notation is going to be a function. So first thing we're going to do with these functions is evaluate them. So they give us the function, so f of x equals, so y equals, here's my polynomial. And they want us to evaluate the function at the x value of -5. So if you're doing that, all you're going to do is everywhere there's an x, so I'm just going to write this, everywhere there's an x I put a set of parentheses, and we are going to plug in the -5, and then just do some order of operations and figure out what the corresponding value is that goes with -5. So -5 squared is 25. And then -2 times -5 is positive 10. So that's 35 plus 7. And 35 plus 7 would give us 42. All right, so that tells us that f of -5 equals 42. It also tells us, just as a hint for later, that this would be the corresponding point, -5, 42, if you were to put that on a graph. So evaluating those functions is an easy way for us to find points for graphs, which is what we're going to talk about next. All right, so the graph of the function is just, they graph all the pairs, ordered pairs. They may connect the dots, they might not, it just depends. So let's just jump right in and look at some examples. All right, so it says graph the functions f of x equals 2x and g of x equals 2x minus 3 in the same rectangular coordinate system. Select integers for x starting with -2 and ending with 2. How is the graph related? Okay, so they definitely want you to have like a nice little, so let's do this for f of x equals 2x. All right, so they want us to go from -2 to +2. So I'm gonna have 5 different values. Okay, so let's just plug them in for f of x. All right, so plug that in. That would give us -4. That would give us -2. That would give us 0. That would give us 2. That was 4. All right, we plot those points. -2, -4, -1, -2, 0, 0, 1, 2, 2, 4. All right, so there is the graph of f of x. Notice very simply we just plugged these each in, evaluated it, got the second, used those points. Okay, now let's do the same thing for g of x. Just be a little bit more careful because it's a little bit more complicated this time. Again, as always, details matter. Okay, so plug in -2, we get -4 minus 3, which is -7. Plug in -1, we get -2 minus 3, which is -5. Plug in 0, we get 0 minus 3, which is -3. Plug in 1, we get 2 minus 3, which is -1. Plug in 2, we get 4 minus 3, which is +1. Graph those. So -2, 1, 2, 3, 4, 5, 6, 7. -1, -5, 3, 4, 5, 0, -3, 1, -1, 2, 1. All right, so notice, connect the dots. Sorry, my drawings, it's kind of hard to draw on this computer screen. So here you go. Okay, so if you look at the 2 lines, of course your graphs are going to look much beautiful and much more prettier than mine because they're just kind of a little sloppy when I'm writing on the computer screen. Okay, but notice the lines are parallel, right? They don't so at the end, how is the graph of g related to f of x? Right? They're both linear and they are parallel lines. So there's lots that you can figure out from those graphs. So just make sure when you're graphing that you're a little bit prettier than mine. An easy way to tell if a graph is a function is it just has to pass what's called the vertical line test. And all that means is that if you have the graph of a relation and you wanted to figure out if it's a function, all you have to do is look at it, and if you can draw a vertical line that hits the graph twice, it's not a function. So no matter where you draw that vertical line, it should only hit your graph once. So let's do some examples. All right, so notice in this first graph on the left, no matter where I draw that vertical line, it's only going to hit one time. So this one is a function. But notice the one on the right, it's a circle, right? So if I draw a vertical line, it's going to hit once here and once here. So no matter where I draw it, it's going to hit twice. So that is not a function. Oops. Sorry for the pop-up there. All right, not a function. So vertical line test, very simple, very straightforward, very easy. All right, you'll often be asked to use graphs to find information. So here, for example, it says use the graph to find f of 5. So we go over here, 5 is the time of the infection. So right here, I'll just draw a little vertical line to help me out here. And notice right here is where it crosses. So let's go over to our y-axis, and that is 400. So what is the average? So find the value of f of 5. That is 400. And you don't really even need to understand the axes or what they're talking about for that to make sense. All it means is that 5 years after infection with the HIV virus, their average T cell count will be 400. And again, that might not mean anything to you, but it might mean something to researchers. All right, for what value of x is f of x equal to 100? So this time you're going to start on the y, and they want you to start at 100, which is right here. It's not labeled, so you're going to have to figure that out. And you're just going to keep going until you hit the graph, which is right there, and then go down, and that will tell you your x value. So that means x equals 9. So that means if you have a T cell count of 100, you should be about 9 years after your AIDS diagnosis. So anyway, just again, reading graphs vary and functions kind of go together, so you can look through those. All right, identifying your domain and range from your graph is a little bit more complicated, so we're going to spend a little time. Basically, what you want to do is you want to take your graph and cast it onto the x-axis, and that will tell you your domain, and then take the same graph and cast it onto the y-axis, and that will tell you your range. So let's just do an example, because I think it's easier if we do that. Okay, so domain. If you see, we're going to take this graph and we're going to cast it down onto the x-axis. So do that every single point from here to here. And notice it's just from this point to this point. That's all of our domain values. So, and there's different ways that you can write it. You could write that your domain is from -2 and it is equal because it's filled in, right? It's not empty. So same thing with here at +2, it is also filled in. They could ask you to write it in interval notation. They could ask you to write it in set builder. So again, just pay attention to the directions. All right, and then when you find the range, you're gonna do the exact same thing, only this time you're gonna cast it onto the y-axis. And it's gonna get cast from both directions depending where you are. So it's gonna start here and it's gonna end here. So it starts at 3. It starts at 0 and ends at 3. So 0 is less than or equal to y, which is less than or equal to 3. So again, if you needed to write that in interval notation, you could write that as well. So there, again, notice you have to cast it onto the axis. So be careful, because there's a lot of places you could make mistakes. All right, so if you want to try this one, you can press pause and give it a try. All right, but I'm going to do it the same way. I'm going to cast it down onto the x-axis. Okay, that's going to get cast up. So the domain is going to start at -2, but this time -2 is not included. So that'll just get a less than sign, x, and then it goes up to +1, and +1 gets an equal sign. So if you're going to write that in interval notation, you would write it like that. And then do the same thing for the y's. Domain, we're going to cast onto the y-axis. And we're going to start down here at -1, and it does equal that. But then here at +2, we do not have the equal sign, because notice it's got that open circle. So if you were to write that in interval notation, that'd be -1, 2. All right, so practice those, because those may take a little bit of practice. If you're finding intercepts, all you have to do to find your x-intercepts is to look where the graph crosses the x-axis. And these I like because if you're crossing the x-axis, you'll have an x value and your y value will be 0. So every intercept will look like that, x-intercept. If you're looking for the y-intercepts, same thing. You're going to look where the graph crosses the y-axis, and every single point is going to be 0, y. You can have a function that can have multiple x-intercepts, but it will only have one y-intercept, maybe no y-intercept at all, but it has to have it can't have more than one. If it has more than one, it is definitely not a function, because the y-axis is a vertical line. So if it's crossing the y-axis twice, it won't pass the vertical line test. All right, so identify the x and y intercepts for this graph. Okay, so let's start with the x-intercepts, because those are kind of the easiest to see. You've got one right here, you've got one right here, you've got one right here. So you've got a -3, 0, you've got a -1, 0, and you have a +2, 0. And then if you want to go find your y, you just have to look where it crosses the y-axis, which is right there, and that point is 0, -6. So there are your 3 x-intercepts and your 1 y-intercept. And you should be able to do that for any graph that you see. All right, so hopefully this was helpful, and we will see you for the next lesson.